If I asked you what mountain range was the longest in the world, I'd probably get two main answers of the Rocky Mountains of North America, or more likely the South American Andes. But in fact, both are nowhere near the length of the longest mountain range. That accolade belongs to the Mid-Ocean Ridge, which is a connected undersea mountain range of 65,000 kilometres in length, or over 9 times longer than the South American Andes. For the purpose of this video, I will mostly be concentrating on its major section, the Mid-Atlantic Ridge. And you can immediately recognise a striking correlation between the shape of the ridge and the shape of the continents either side, which is especially notable between South America and Africa. This is no coincidence, as in fact, many millions of years ago, all the continents converged together into a supercontinent that we today call Pangaea, which began to split again around 175 million years ago. The creationist organisation, Answers in Genesis, also believe that Pangaea existed at some point. They simply disagree with how long ago this was. And Dr. Andrew Snelling, who is an actual geologist who used to work for oil and gas, he wrote that the landmass God formed on day 3 of the creation week was probably a supercontinent. Then that supercontinent broke apart during the flood and continental sprint opened up today's Atlantic Ocean. So instead of the continents drifting apart over hundreds of millions of years, creationist organisations believe that this split happened just over 3,000 years ago, and continental sprint is their explanation for what most geologists call continental drift. And so the only question left is, how do we know how quickly the continents moved apart? Is it a sprint or is it a drift? And for some answers to that question, we require a slight tangent. Everyone knows that a compass needle points directly to the North Pole, but not everyone realises that it's pointing to the magnetic north, not the actual geographic north. Or perhaps it's more accurate to say, not everyone realises that they are not the same thing. The reason they are different is that the geographic North Pole never changes, whereas the magnetic north does. This is due to the Earth's magnetic field being dependent on the mixture of molten iron and nickel in the Earth's outer core, which changes over time, causing the pole to shift around. And in fact, since its first discovery in 1831 over North Canada, the North Magnetic Pole has travelled around 2,250 kilometres, or 1,400 miles. Like I said, it was first discovered in northern Canada, and since that point, it's been moving across the Canadian Arctic towards Russia. And as you can see, the South Pole is also wandering, and is now in fact off Antarctica. Now the movement is generally quite slow, but we can see in this animation that since the turn of the century, it really sped up and started rushing towards Russian Siberia. And that was at an average of 55 kilometres per year. And it was forecast in the World Magnetic Model 2020 report that it would continue on a path towards Russia, however at a slower rate of 40 kilometres per year. There's no guarantee it'll actually get there, of course, because it could easily start to return back to Canada. Or, as you'll discover later, somewhere entirely different. Alright, but what has this got to do with the Mid-Atlantic Ridge? Well, first of all, the Mid-Atlantic Ridge is the point at which the North American and Eurasian continents are drifting apart. And what I called a mountain range is in fact a volcanic mountain range. It's similar to what we saw with the Hawaii hotspot in the previous episode, except on a massive worldwide scale. What's the evidence for this? Well, Iceland and its 130 volcanoes, of which 30 are currently active, is a pretty strong indicator. Notice Iceland's position smack in the middle of the Mid-Atlantic Ridge. And recall the explosive eruption at Eyjafjallajökull in 2010, which affected European air travel for over a week. Iceland is 6 times larger than the Hawaiian Islands, and it is currently expanding at around 2.5 centimetres per year, which is a similar rate at which the Mid-Atlantic is drifting apart. You can actually stand at the spot where the North American and Eurasian plates are diverging due to a process called ridge push, which is beyond the scope of this video. What's important here is that at the Mid-Atlantic Ridge, magma is constantly rising up through the volcanoes before cooling to form new seabed on the ocean floor. And due to ridge push, this seabed is spreading across the Atlantic in both directions. And here is where this story takes a very interesting turn. You may recall being shown at school how iron filings can be moved around using a magnet. And that's because the atoms in the iron are attracted to the opposite pole, similar to a compass needle. And the magma which rises up from the mid-Atlantic ridge also contains iron. And when it cools and hardens, the atoms inside the iron line up in the direction of Earth's magnetic field at that point in time, which leaves a permanent magnetic pole imprint in the volcanic rock. In the 1960s, research ships towed magnetometers, which are devices capable of measuring the direction, the strength, and the relative charge of a magnetic field. These ships dragged these over the Atlantic Ocean, and they uncovered clear evidence of a process which had long been hypothesized. The Earth's magnetic pole had, at multiple times in history, flipped between the north and south. The research ships found magnetic stripes of rock on the seabed running parallel to the mid-Atlantic ridge, which contained iron polarised to north, then south, then north, then south again, etc. Now, previous to this point, some rocks on land had been found which showed evidence of a magnetic reversal. But what was discovered on the seabed created a revolution in Earth sciences. This magnetic profile here is from the ship El Tanin, which crossed the Atlantic in 1966. The top line shows a change in magnetism from west to east, and the middle line shows a change in magnetism from east to west, which reveals the clear symmetry either side of the mid-Atlantic ridge. The stripes are symmetrical either side of the ridge, and that alone is very strong evidence of seafloor spreading in the opposite direction down the ridge. As you know from the previous episode, using radiometric dating similar to the method used for dating the rocks on the Hawaiian Islands, the age of rocks on the seabed can be dated. Rocks closest to the mid-Atlantic ridge were found, unsurprisingly, to be the youngest, as they've just recently cooled from their magma stage. And the further from the ridge the rocks are, the older they are. And by using a combination of potassium-40 to argon-40 dating, along with the more accurate argon-40 to argon-39 dating methods, the length of our current polarisation, that is, the period we're in now, was determined as 780,000 years old. And it was discovered that in the last 5 million years, pole has reversed 24 times. And as you can see, sometimes the direction lasts a long time, as is in the case currently. And sometimes the switches are very brief, like what happened at 1.19 million, 2.08 million, and 2.14 million years ago. There is no obvious pattern to these reversals. This is statistically random. Now, the creationist organisation, Answers in Genesis, does not dispute the occurrence of these magnetic reversals. As usual, they simply dispute how long ago and how quickly they occurred. According to their resident geologist, Dr. Andrew Snelling, who promotes the catastrophic plate tectonics model, these magnetic reversals occurred rapidly during the flood, while also noting that the Bible does not directly mention continental drift or plate tectonics. However, if the continents were once joined together and are now apart, then the most likely time for their division was during the flood. So in a sense, we have this creationist model where the continents sprinted apart, continental sprint, during a worldwide flood some 3,000 years ago, before presumably slowing down to their current rate of only a few centimetres drift of today. This model appears to fall flat, however, when analysing the situation elsewhere at the mid-ocean ridges. Magnetic profiles across the Pacific-Antarctic ridge, this one here, were soon also discovered to be symmetrical and matching the pattern in the North Atlantic ridge, but with one major difference. The rate of spread was clearly much faster in the Pacific. Eventually, the same magnetic reversals were found over most of the world's oceans, just with different spreading rates. And we can see that in this glorious age of the ocean floor map. The Pacific-Antarctic ridge has far more younger rocks, younger shown in red, whereas between, say, Africa and Antarctica, the rate of spread is slower than even in the mid-Atlantic, which is pretty slowly spreading. But these same magnetic reversal patterns remain no matter where you look. And what's more, deep sea core sediments, similar to the sediments from Lake Suigetsu we discussed in the second episode, uncovered tiny microfossils which matched the magnetic spreading rates. And finally, when we look at the GPS today, we find exactly what the science predicted we'd find, way before GPS was even a thing. The continental plates are drifting apart at different rates. much faster in the Pacific. The length of the lines show the speed of the continental drift, and we clearly see Australia moving quickly away from Antarctica, exactly what the age of the rocks show on the sea floor, but much slower in the Atlantic. And if ever you needed evidence that Iceland is being pulled apart in two directions, there you have it. And these spreading rates give us an age of the seabed at each location on Earth. And the oldest seabed we can measure is around 180 million years old, off the east coast of America and the west coast of Africa, the point at which Pangaea first began to split. The creationist position collapses when geology, paleontology, paleomagnetism, chemistry and physics work together to give us the clear, big picture of how Earth is evolving. There's no need for speculation of continental sprint. There's no need for catastrophic plate tectonics. And there's no need for any global flood, for which the geological record contains absolutely no record of. The seabed proves the Earth is at least 180 million years old, which is so many times more than the 6,000-year-old creation fable that I don't even need to do the maths. But we're still only at the 100 million stage, and the claim by modern science is that the Earth is billions of years old. And in the next and final episode of this Real Age of the Earth series, I'll detail why we know that is the case.